Hi everybody, I think we are now live on Facebook, so thank you very much for joining us for this talk today. This is part of Tech Week, which Creative Folkestone is hosting as part of the Southeast Creatives Programme. That programme I'll talk a little bit about at the very end of the meeting for those who would like to know a bit more. But the talk today is called Designing Architecture in Virtual Space Using Unreal Engine Gaming Technology. And I'd like to welcome Paul Sims, Fabrice and Howard Griffin, who are going to be delivering this talk today. Paul, can I hand over to you, and then I'm going to switch off my video and speaker so that you can talk quiet without me in the background. And yeah, welcome to Paul, who's going to carry on the talk. Thank you.
Great, thanks, Karen. Yeah, the purpose of our talk this morning, as you've already highlighted, is to discuss the ways that architectural design is going through significant changes. We basically, in terms of 3D modeling, virtual reality, and using gaming technology. These are all kind of becoming more and more prolific, and we're using them more and more day to day in the work that we do. The principles that we'll be talking about today are also applicable to other fields of design, obviously, and these technologies have been using in the car industry, aviation, film, television, fashion industries, to name but a few. So just to paint a picture, I mean, obviously our office and our home computers are now becoming more and more capable of handling large 3D models and can deliver the kind of computing power that we need to be able to drive them. At the same time, thanks to the gaming industry, some of the software is becoming more affordable and more accessible to us all. So what do we use the technology for? Well, we founded Profile Architects 2.5 years ago, and we've been working on a range of different projects in all sorts of different sectors, residential, commercial, and our projects vary in scale and complexity. From very small projects up to the largest sort of scale, sort of master plan projects. We decided when we first started out that we would design every project digitally in 3D. And it's worth just briefly, I think, explaining how the process works in terms of design in architecture. I mean, essentially, every project starts with a site visit and discussions with the client about their aspirations. Usually the next stage is a site visit and discussions and to develop the brief. And we usually start by hand sketching. And this is really where the creativity begins. We also start to use physical models, make cardboard models, foam models to test the ideas in 3 dimensions. But we quickly like to get our design into a digital model. And at that point, we can really start to test using the site constraints, the site boundaries. We model the topography of the landscaping of the existing sites for a typical project. And then from there, we can start to cut and carve the 3D model and turn it into something really useful. We use a program called Revit as our primary modeling tool. It's not necessarily the easiest software to use, but it is a market-leading piece of software in terms of BIM, which is building information modeling. And it allows a sort of amazing workflow from the initial outline sketch design through to producing detail models and schedules and just getting that workflow going, using one model to create all of that information. So if I just quickly share my screen, hopefully this will allow you to see, hopefully you now see the 3D model there. Please shout anybody if that's not showing up. But this just is an example project, and this just shows how a dynamic 3D model, if I just move that around, allows us very early on in the design process to investigate, to test, to push and pull, to select items, to remodel, and just try different ideas out until the design starts to come together. And of course, and this is Revit, and this allows us to add materials and various different elements to the design. We can also cut the model and look inside the model and see how layouts are working. And again, this can be rendered and see how materials are working. So I'm going to unshare my screen again, if I can do that. Sorry, 1 second. Sorry, apologies. There we go. Okay, so that just gives you a rough idea of how a 3D model might look to us as we're working through that scheme. And as I say, we build a model like that for every project, no matter how large or small the scheme is. It just allows that workflow to happen. I think what's significant about working with a digital 3D model, again, as early as possible, is the ability to show the client and any other design stakeholders, consultants, engineers, can show them views of the emerging design. We can get eye-level views, we can do bird's eye views, as you've seen on the screen there. Of course, the next thing though then is that if we want to then supercharge those images and start to become photorealistic, then we need to go to the next level. So by and large, the way it's done in the industry is that we go through then a process of creating those photorealistic images by rendering scenes. Traditionally, that would involve setting up a view, telling the computer what materials are and lighting, and then letting the computer render it. And that rendering can often take hours. I mean, it can even take overnight for, often people will leave things rendering overnight and then come in and sort of see next day what the result is. But that way, the process is very much detached from the workflow, meaning that, and there's also quite a lot of post-production that happens, adding in details and people and trees. So I think, where we're moving on to now is that the technology is moving on, and that with the advances of both the software and the hardware, it's now possible to render in real time using techniques basically developed in the gaming industry, meaning that scenes can be rendered instantly and we can get instant feedback from those models. So we're then able to walk through photorealistic buildings and landscapes in real time and explore the design more thoroughly as part of the iterative process. So as architects, we can now use this software to test space, test light, materials, reflectivity, and so on in real time, making it more of an effective part of the design process. It's these opportunities really that draw us, draw us into using the digital models as soon as possible. Now, we've been discussing ways of doing this with Fabrice, who's joined us today. Fabrice is an expert on using real-time rendering and works for Epic Games, teaching architects how to use the software. He'll tell us more about that software in a short while. But before we move over to Fabrice, I'm going to introduce you to Howard Griffin from Kent School of Architecture, so he can explain how some of the students and himself have been using real-time rendering software as part of coursework, and also been working on some very interesting collaborative projects. So if I can hand over to you now, Howard, that'd be great.
Okay, thank you very much, Paul. Good morning, everyone. I'm just going to share my screen as well. Fingers crossed. So hopefully you can see this PowerPoint. I've got a few slides here to explain how at the University of Kent, in the Kent School of Architecture and Planning, we've been using VR and working in virtual space, both as a design tool, but also as a visualization tool. So my primary role within the School of Architecture is as the program director for the Masters in Architectural Visualization. So the what Paul was just talking about, the traditional way of creating photorealistic images of what your building will look like is a process called architectural visualization. And it's usually something, it's a presentation tool. It's usually something which comes at the very end of a project. The rendering times can be enormously long. And particularly the more complicated the building becomes, then the longer it will take to render. And as Paul was alluding to, it's not an iterative process. It's very much about a final sort of a final presentation of your scheme. There's not much feedback from that because of the length of time it takes to do the renders. But part of that course is what we've been looking at in that master's program is the notion of virtual reality. So we've been using VR since 2010 now to explore how it can be used in the architectural visualization industry, and of course it's now becoming ever present. It's still not taken over from static renders yet, but it's well and truly on its way. And I know Fabrice we'll be talking a little bit about Unreal Engine shortly, and how that's really changing an awful lot of the way we look at architectural visualization. So I can just run through a few slides here, just to, if it will allow me. Yep, there we go. So we've been using, this is our head of school, Gerald Adler, using some VR here. He's not designed it, obviously, but this is a student project who his task for his dissertation project was to visualize, to put into a 3D model a house. It was called the Endless House by an architect designer called Kiesler. And it's one of the projects that he chose to do as a dissertation, was to try and actually put this in, make it actually happen. And that's one of the great things that VR does for us, is it allows things to actually become a reality, in inverted commas. So these are my students here, and one of my colleagues, Mike Richards, who are all using different VR kit to either experience or to visualize some of the work. And I think this is something that's really important to get across. If we're showing you static slides like this, and you're looking at it through your screen or your phone or something like that, if you've never used VR before, it's really difficult to understand how incredibly immersive it is. It's not until you put the headset on that suddenly you're transported to being inside that model, or being inside that space and so on. And that's a key thing about VR, virtual reality, is that it's very much the process, or it's the experience of the user which becomes the primary thing. So with most architecture design projects start with a plan, typically, not always, but typically start with a planning exercise, laying out where you want the rooms to be positioned, the sizes of those rooms, how they might interact with perhaps vehicular or pedestrian access, that sort of thing. And so it's a case of sort of plan, like map drawing, effectively, for those that are not really into architecture. But you never experience a building in plan, and you certainly never experience a building in elevation, which is the vertical sort of facade of a building. We never, and we also have other drawings that we use as architects, like sections, where you're cutting the building in half, for example, so you can see how spaces and perhaps floors interact with each other. But again, we never experience a building in that way. We only experience buildings through perspective, through our eyes, and so that's where VR is really coming into into prominence, because it allows you to design space from an experiential point of view. So you can walk into space and feel and understand and experience what it feels like to be in that space, rather than how big it is on a piece of paper. So the main project we've been working on in the architectural visualization program is a project at St Augustine's Abbey in Canterbury. For those that don't know it, this is what it used to look like. This is in its heyday, back in early 1500s. And at the Reformation of King Henry VIII, it was closed. He didn't take too kindly to the monasteries and so on, and closed them all down. And it then progressively, over years, over centuries, it went into ruin. And this is what it looks like now. So this is what's left, and you can see the main abbey church. I don't know if you can see my pointer here, but the main abbey church in the centre, with the cloister just above it, and the buildings which are still complete, which are not the original buildings, but they're replicas of the original buildings. That's King's School. So then just at the bottom of the image here is the Longport car park. So for those of you that are familiar with Canterbury, you'll know where this is and so on. But when you're visiting the site, it's very difficult to fully take on board the magnificence of this building. So we're very familiar with Canterbury Cathedral, and the scale of that building, the magnificence of that building is apparent as you walk through it or around it. But St Augustine's Abbey was a building of equal sort of magnitude, and it's really easy to begin to understand how important Canterbury was as a place for pilgrimage, when you had two such prominent ecclesiastical sites in the city, one just inside the city, one outside the city. So one of the things that we've been doing is to create a virtual reality experience, and hopefully this video is playing okay. This is what you can don when you go to the museum. You can put on an Oculus headset like this, and literally experience what it's like to be, or to stand outside, or to be inside the Abbey Church as it would have been. This is an experience. It's completely hands-free. So you look at when you're using the experience, you point the cursor in the middle of the screen at one of these blue balls, and it will then take you inside, or navigate you to where that ball is located. So one of the things that a lot of users who are using this for the first time remark is that actually it allows, the video's just stopped there. Okay, that's right. Carry on. It allows viewers to really understand what the building looked like, how big it was. The scale was really, really important. As you can see, it's an enormous building, very opulent as well. Lots of color and decoration, and it enables people to, when they're going to visit the actual site, the physical remains of the abbey, it allows them to really fully understand. They can repicture. They stand in the middle of the nave, or what used to be the nave, and with the VR, having been armed with this visual information from the VR experience, they can then really sort of reimagine that whilst they're standing on the site. But this year we've been doing things slightly differently. This is something that was planned right at the very beginning of the year, but it came to prominence because of the COVID lockdown, and it became incredibly useful for us. So on this slide here, this is a typical architectural presentation in first year. This is two examples of a gallery project, which is to design a gallery on a site in Canterbury near to the Miller's Arms, just by the St Radigan's car park. And the two sort of typical examples really about how students would present. So it's exactly what you would expect from an architecture presentation. So you can see some on the left hand side. You can see two plans on top of it, two drawing sheets with plans. This curvy plan. And that's the typical way that we would explain how you go through a building, or how a building has been designed. And then to the left of that, there are some perspective images and an elevation. And this is very traditional. So you can see the model at the bottom. This is what we would expect students to produce. But of course, come in the middle of March, when the university campus was forced to close, students went home, didn't have drawing boards at home, didn't have the ability to produce these large drawings as they would do normally with our studio facilities. So we were kind of forced into a position where students would start to have to use different means to communicate their design space. And this became an opportunity rather than a hindrance. So the software that we've been teaching students this year is sort of 3D modeling programs like Rhino and 3D Studio Max. But in addition to that, we've also started teaching them how to use Unreal Engine, the software that Fabrice is going to talk about shortly. In addition to that, we've also been using a new program, relatively new program called Twinmotion, which is an add-on really to Unreal Engine. So you can add things from Unreal Engine and from other software programs into Twinmotion. It's a very, very, very quick and easy drag and drop program really, where you can just drag 3D models into it and populate it with people, add materials, put water in there, trees. The landscaping facilities are absolutely fantastic in Twinmotion. And you can produce very quick real-time realizations of what this space is going to look like. So this is what our students have been doing this year. Obviously with our laptops at home, in their own bedrooms and so on, we've been producing work like this. And this is exactly the same site that we used this year. This is year's work compared to last year's work. And I'm sure you can see the benefits of being able to work in a piece of software like this. And going back to what Paul was saying, what we'd like to do is for this whole process to become part of the design process rather than just the presentation process is the key. So the speed and the efficiency with which you can just drag your buildings into here and test it without too much investment of time, too much investment in terms of material, adding materials and so on. If you're not investing too much time in this, you have the ability to then go have a look at the design and realize what's not working and go back and change it, because there hasn't been this huge investment. You don't feel attached to that particular design or that building because you haven't invested so much time in it. It's you can then move on, develop the design, revisualize it, and carry on. So, and one thing that's really remarkable about this video here at the moment is this is first year. This is not 5th year or 3rd year. This is first year level work. So they go into our 2nd year armed with these skills, ready to start working on their much larger projects next year, and of course there onwards. And this is something that the industry will have to contemplate in terms of the students that they're employing, is that these students will be armed with this information and this knowledge and these skills about how to use this software. So it's actually, so from the bottom up, it will be changing the industry as it goes. One of the last things that I wanted to quickly show you before I hand over to Fabrice is that the next thing that we want to do in the School of Architecture is at Kent, we're very keen to maintain traditional methods as well as innovating new methods. And so we insist on the sketchbooks, we keep drawing boards, we do work in traditional means. But one of the things we're looking at doing this year is introducing a program using VR called Tilt Brush. And Tilt Brush is a painting program, but for VR Oculus headset units. So I'm just going to show this as a Tilt Brush advert, but it shows you the sort of thing that's possible. And one of the things that I realized when I first started using VR, I'll just turn the volume down. I don't know if you can hear the volume or not.
We can hear it.
You can hear it. Okay.
Yeah, it's better now.
I'll just let that play for a second and then I'll pause it. Anyway, you get the idea. So one of the things I realized when I first, the early sort of iterations of Oculus, the DK1, was that you could draw a space. You could draw a sketch in 3D, a sketch of a building, of a house, a room, or anything like that. But then you could scale it up, and you could scale it so that you're actually inside the space. And so that's really sort of continuing what Paul was saying about designing space from within it. So it's an experience perspective rather than a godlike looking down on your building plan kind of view all the time. So that's what we're planning to do in the School of Architecture for next year. And more news about that later. I'll hand over to you, Fabrice.
Great. Thank you, Howard. So I guess I'm all unmuted. So if everybody can hear me. Thank you. So that's fantastic. Basically, I'm just really taking on from Paul and exactly what from Paul and Howard said, and I fully agree with everything that was said. So it's really exactly sort of taking on from Paul's kind of Revit model, which is all 3D. In the olden days, I had to kind of model that using 2D plans. Now that's very, very unusual. And also from what Howard's kind of showing, building, well, usually it's buildings that have not been built yet, but it's really interesting to see, how that's done to revive the past in a way. So I'm going to share my screen. So if I need to be made co-host, I think. Host disabled participant screen sharing. If you can make me co-host, I can share my screen. There we go. Excellent. Share screen 1. All right. So I'm going to just say a little bit about the work that I do. I'll show you a couple of images from back in the days to show the contrast, the difference that basically Howard was talking about. And then I'll show you a couple of examples of what gaming technology is, and then we'll go into the software, into the project here, and then I'll kind of give you, kind of live demo here. So I'll just flash my website because it's the thing that's kind of most up to date. I do these sort of images now using that site, that software called Unreal. I've been in architecture visualization. I actually trained as an architect, but I've been doing visualization forever, since 1996. And I was very fortunate to work with all these kind of big brands, and very, very much on the front end of sort of winning jobs, pitching, or doing big sort of presentations internally for companies like Google and Bentley. It was rebranding. So using the 3D as a design tool, very, very much so, and interacting straight with the designers, and so that's very much where I came from and what always interested me in this tool. In fact, I did my architecture diploma on the subject of 3D as a new tool, and the idea was that it was going to change the way architecture looks. So now I teach Unreal. I work as a contractor for Epic Games. I teach Unreal 2 architecture and everything related in that what we call vertical, because at Epic there's several verticals, one of which is game that I'll talk about in a sec. And there you go. And I kind of worked with Thomas Heatherwick in very early days. So I watched the whole progression from when there were very little, sort of 5 people in the company, to now where they've designed Google headquarters and things. So Unreal Engine, what is it? Obviously, you have heard of Fortnite, so I'll just play this while I talk over it. It's a video game, and obviously the point about video games is that it's real time. Everything's moving, it's interactive, all the characters are moving through the space, as opposed to in fact, I'll show you some images now, as opposed to these images, which are kind of things I've done throughout my career. These are for the Week Studio, kind of big static images in which we kind of zoom in, and there's a lot of photoshopping that works, and a lot of detail, and these take very, very long to render, and and are pretty expensive as well. So when you think that a property developer maybe is going to have to, sit on these for, maybe, when they're built, for the sales brochures and everything, the building maybe, the image may have to live on for maybe 20 years, of the building needing to be presented and sold and so on. So these have worked very well. These are really, really old, from Battersea Power Station and so on. So, but they have their inconvenience, as was highlighted before. So came Unreal Engine a few years ago in 2016, which is when I started working with the software, and more recently a new kind of technology, which was on what we call the CPU. So the images that you've seen are using this technology called ray tracing, and now we have this ray tracing technology that is moving into the GPU, which is what is used to render out games. So what you're looking at now was the first demo that was output by Epic Games using this technology. And what that means is that basically we have now technically the ability to render out video games that look like Hollywood blockbusters. Like Lord of the Rings, Transformers, all these kind of things. So this image here, normally on a CPU, on a computer, would take, however hours to render. Maybe on a single CPU, it could take 5-6 hours to render. But now the restriction that Epic Games on producing demos like this, which is a movie, but the restriction is that it has to render at 25 frames a second, which means that this image took 40 milliseconds to render, right? So that's a little bit of math and complicated numbers, but it means basically a complete total revolution in the industry and this is what I'm talking about, these verticals at Epic Games that we have. This is the automotive, so it's a complete revolution in not only the way the automotive industry is being marketed, a lot of adverts are using this kind of stuff, but also in how it's being designed. Tesla, for example, is a big client of Epic Games, and so they're using Unreal Engine for artificial intelligence, for driving cars virtually through, you know, millions of hours of road, and also rendering out these visuals. So it's got a lot of repercussions in many industries other than architecture and automotive, you know, things like engineering, simulation, medical, a lot of defense as well, and the movies. So we're seeing a lot, obviously. Mandalorian was is done using Unreal Engine today. So okay, so I'll talk to you just a little bit about some of the videos I've got here, just to kind of show you some examples of large architecture, and then we'll go and have a look at some smaller things. So these are kind of just videos I've got on my channel that you're welcome to look at here. I'll just flash through these sort of little demos where you can really now take this technology and start using, well, just like Howard showed us, really, the inside of the building. So again, these are little movies, but you can see how we're really narrowing the gap between what we are sort of used to seeing in terms of a video game and what we can now render out using the same technology. Okay, so I'm showing you these videos because these files kind of take a little bit long time to load up. So rather than load them up one by one, I'll just show you the pre-rendered version. Okay, so hopefully that all makes sense. So now I'm going to take you inside the software. I'll show you a couple of projects. One which is just a sort of little room like that, which you can, you know, if you want to try this at home, or you can see, you know, the level of fidelity. And then I'll show you another project, and both of these are projects I use for teaching at Epic. And then so we'll go into the more of an exterior, and I'll show you a little bit how we can get some pretty fancy stuff going very, very quickly. So so basically this project is a project I use in to teach, and so I'll kind of rebuild this scene a little bit from scratch just to kind of show you how it works. So I'll kind of just dive in, just a very, very quick view of what that looks like. So sorry, I haven't got that set up as I meant, so I'll go through like this. So basically, as it starts, we have a 3D model which kind of looks a little bit like it would under Revit, like that Paul showed you, and then we kind of just build the geometry by importing with a plugin called Datasmith. So in the olden days, it would be quite a skill, and in fact we have entire companies that are based on this in order to build those 3D models, you know. And Howard saw, like showed you, that the church that took quite a lot of man hours. So now we can cut this down very, very quickly using this software called Datasmith, which Epic has developed, in order to import those models very, very simply. So and without any what we call preparation or data prep, which was a big hurdle in using this software, you know, in a kind of easy way. So now literally with this one button, we can import all the stuff from whether it's SketchUp, Revit, Rhino, whatever you have, really, AutoCAD, Blender, and so on. So it becomes very, very easy and simple to transfer the model from one to the other. Then what we do is that basically it's called building the lighting. It's just shining light, if you want, onto this model. And this is where we come very close. I'll hide some of these things. I'll go full screen because there's no point in So here we're very close to kind of the architectural process, you know, of building these little white cardboard models. If you've ever been near an architecture firm, you know, we'll have these cardboard models or everywhere, studying space and light. And here the beauty of it, and if I just hide this little guy here, I'll show you interesting view. The beauty of it here is that we can actually start having any of the very, very creative with the types of views we can have. I'll narrow my viewpoint a bit. And so I find that is very interesting that we can kind of start having real sectional views, for example, which those I remember in my student days actually drawing those massive drawings, laying them out with lines and rulers, you know, and these would take hours and hours and hours of work, and yeah, and they would become very precious. And when when somebody is destroying your design on the wall, and you've spent, you know, 15 hours on the drawing, you're like, oh, it's not fun. So this is really something that enables us to well, to present and to communicate. So obviously when we're at student level, we're presenting a lot and getting a lot of criticism, feedback from our teachers. But as you go into the world, you know, and you've got to present these projects and pitch and so on, it's a real communication tool inside the company or within the teams, within the different consultants and everything. So I've found, you know, the proof over and over and over again that the benefit of these, if there's anything, you know, that's kind of going to be pinned on the wall for reference, very often it's going to be the 3D render, and people are like, oh yeah, that's what we want it to look like. In fact, that's exactly what happened when I worked. I'm just see if I've got the. This is exactly what happened, and this is a render old style, right? This was a few years ago, but this was the first building that Thomas Heatherwick built in Singapore, and they were really struggling to design this facade in Rhino. And in fact, we did a lot of pushing and pulling using 3D modeling software, and this is exactly what Thomas Heatherwick, we finished. Finally, we got agreement. He was like, we're building that. And that was the reference for the whole thing in the end. So imagine when you can kind of, you know, say we're building that, but you can carry on changing it. You can have some very, very realistic kind of materials, being able to depict materials in a very, very realistic way. So this is kind of, you know, I'm kind of showing you around, trying hopefully to show you how realistic we can get now. And this is the point of this little class I teach. So, you know, this is kind of super easy actually to get to this level. You know, when I teach students, within a few hours we can get to this. This is a 2-hour class. You know, it gets a bit dense, but afterwards we get you know, for in a day you can really get good grasp with this. So my favorite bit is when we get to the next stage, which is then adding lights. So here, this is a night view. Okay, and I'll show you about how all this gets a lot more interactive in just a sec. But this is a kind of a night view, which really enables you to, well, to start exploring the design as a place, you know, placemaking. And I call it sort of theatrical design, really, because when you start putting light, it's like lighting a stage. And all sorts of really interesting things happen, you know, when the space can completely change the mood, but also the performance of people inside, you know. So it becomes, it's another thing about game design or designing within a gaming software is that, and I'll just make this little parenthesis, is that when you render a movie or you go to the movies, if you go to the movies tonight, you'll see a movie, and then you go again tomorrow, you'll see the exact same movie. But when you see a theater, when you go to the theater, you will see the play tonight, and if you go again tomorrow, you might see a completely different play, right? It might be a different actor, it will definitely be different public, it might be different delivery, and so on. So this is what I like to kind of teach and show here, is that we're kind of closer to the live performance of theater, and it becomes there's something quite exciting about that. Okay, so I'll move over to the other project quickly, and then hopefully we'll have time for a few questions. So this is another bigger project, and so I kind of show you here where things get very exciting in terms of interactivity, because this being all completely well, not only real time. So this is what I mean by real time, is that I'm actually kind of moving around here. This is not a fixed camera point. I'm like in a game, but I can also start moving things around. You know, like if I don't like this tree here, I can move it over there, which is not what you normally do. You don't normally move trees around, but here, that bench, I can definitely do that. And the way this is kind of configured, I can actually scale this, for example. You know, I can move it and change it as I want, like that. So this is a very crude little example, but in fact, this entire building was modeled using this technology, where I can actually, so I might have to swap this one around, right? No, it does. It's using the technology where I can basically swap these elements around and design as I want, just like in a game. So I need to change level to show you that. So I'll just show you the interactive bit here with the animation. So what I've done, and this is again part of a lesson, is that we've got what is called a procedural sky. So that means the sky here can actually move. So if I'm changing the sun here, I've animated the sun in my kind of little animation bit here, and called sequencer, and actually move this. The sun is moving down below the horizon. So that means this the light is interactive, is changing absolutely interactively, is that, if that's the word, in the software. So I'm actually able to also program the lights to turn on. As you can see, they're just turning on there. And also, as I'm moving the slider, the lights inside the building are moving in. And then the lights inside the building have got a sort of funny effect here, where they look like a little bit like something's happening inside the building. So this is again happening all in real time in front of your eyes, without any pre-calculation. And then now I've actually got the camera moving, and I can do a little animation like this. I don't know if it's playing fast enough for you, but here where the camera is moving, the light is moving, the lights is turning on and everything. So I've done a lot of animations in my career, and I've usually had a battery of, you know, a dozen, sometimes 15 computers on behind me, you know, getting hot, pulling a lot of power out of the wall, and to create these animations, which have a lot of values for clients and users alike. So now to be able to create these animations, and literally I still have my own clients still, as well as teaching. And last time I rendered on a laptop on my sofa in 20 minutes. It was quite a feeling. And the clients were very happy. They won the job and they came back, you know. So it's yes, it's definitely the future. But the future, you know, is when we talk about VR and putting the goggles on, like that Howard was talking about here, in terms of rendering these animations. The future is definitely now. So yeah, if we've got time for questions, if we have questions.
Hi,
yep.
Fabrice. Yes, we've got a bit of time for some questions. I think we had a couple of questions earlier on the chat on Zoom, and we've had a couple of questions coming through on Facebook as well. For those of you on Facebook, hi Chris, hi Aaron, hi who else we've got? We've got quite a few people on here. Can I start with a couple of questions on the Zoom chat, because Facebook's a little bit time lagged, so they can be starting to get their questions typed in now. So I could see earlier there was a conversation, sorry, I'm scrolling up. If the people who are on the Zoom meeting want to join in with their audio, you'd be welcome to join in with the audio. I think we've got Jeremy and Gabriel, or Gabrielle. You can correct my pronunciation in a minute. If you want to join with your audio, you're welcome to ask questions, or I can just read out questions that were typed in. Gabriel asked, how can one obtain the Unreal Engine software?
Yes, so here, if you can still see my screen, I've just brought up the website. So you just put unrealengine.com and you can download it right here. So you will need to create an account with Epic Games, and it's completely free. You do sign an agreement saying some things which is worth reading, but it is completely free, and you do need a powerful computer.
Right. On the Facebook feed, we had a couple of questions. How long does it take to render something like this?
Well, that's the point. It doesn't take any time. It's like you take a screen grab. Whatever you have on your screen. In fact, I rendered an image once at 16,000 pixels. So I don't know if that means anything to you, but it's absolutely, it's, when you go to the cinema, it's rendered at 4K. So this is 4 times that. And normally I wouldn't even attempt that. It would just be crazy just to load that in memory. But I did it here and it took 4 minutes.
And
to put that into context, Karen, as well, so when we're doing our rendering static images off of other sort of the traditional programs, that sort of image would take hours, days, sometimes weeks, depending on what sort of materials you have on there, because if you have lots of glass and it does lots of calculations and things like that, so the speed that Unreal does this at is a huge time saver. Yeah.
I can imagine that impacts so much for you as well, because you presumably makes your productivity much better as well, because you're not spending so long. Yeah,
absolutely.
Another question, it says, is the lighting taken from the manufacturer's specifications? Obviously, I'm not quite sure what time that particular message came in, but it's fairly recent. So is the lighting taken from the manufacturer's specifications?
It can be.
So yeah, that's I guess you can use IES lights, which is IES is a manufacturer's format, widely used, and you can use those files to specify lights. It's not Unreal Engine currently, because it really comes from decades of development in games, is very much based on cheating. It's a very artistic process. So it's closer to painting than to kind of real life simulation, although it's moving that way due to this ray tracing technology. So it's moving that way, but it's going to take several releases. It's a slow process.
Great. I see that Jeremy's joined in the conversation here.
Hello.
I think if Jeremy wanted to ask any questions, I've also got one from Gabriel on the chat as well, but Jeremy, you go first and I'll bring in with Gabriel's afterwards.
Okay. I currently have a workflow where I use Revit for modeling, just as Paul does. And then I transfer back and forth to Twinmotion. I'm keen to move over to Unreal for a couple of reasons. One is the quality seems so much better, what you can achieve with the lighting. So I have a question about the workflow, moving from Revit to Unreal using Datasmith. Is it a back and forward situation, or is it just once and then you have to work on it from Unreal from then? And what do you do if the design changes? My second question would be, the other reason I'm keen to move into Unreal is the interactivity. So in terms of producing like a game that you can present to somebody, you can give to a client, where you have buttons you can push, you can turn lights off and on, you can open doors and close doors, or anything you want. So I'm not sure who's the best to answer that, perhaps Fabrice.
Yeah, so currently the transition from Twinmotion to Unreal is not yet available. So today you don't have this option of moving from Twinmotion to Unreal. I've heard about this, it's been in discussion for the last 2 years. So this I've heard 2 years ago. Yeah, it's about to come out. So It's about to come out in July. I've heard that we are going to have this functionality of moving from Twinmotion to Unreal. So your other questions, I don't know. It's yet to be seen. Again, Unreal is a funny company compared to other companies like Autodesk, for example, where they have a roadmap and they follow the roadmap. Whereas in Unreal, it's very much based on users, people in the company using the software and developing, and the interaction with the customers and things like that. So do get involved and voice your needs and stuff. But yeah, sorry, Howard, you go ahead.
No, I was just going to add to that the way that that Unreal is developed is totally different. So it causes us huge headaches at the university, actually, because every year we have to update our software when Autodesk bring out their next version of Revit or 3D Studio Max, whatever. But we have to do that on a monthly basis with Unreal, because they're bringing out updates all the time. And I think that really shows how interactive epic games are in terms of responding and adding features. And these updates are not minor patches. They're these are massive introductions of new functionality every month, sort of thing. So it's growing all the time.
I think picking up also just on that, and also on what Jeremy was saying, the idea that packages such as Twinmotion really are about a presentation of a model, but the fact that Unreal can go so much further and can actually create animations, the interactivity that you were pointing out, being able to switch lights on and off, it becomes more than just a presentation tool. It becomes a real masterclass and allows so many other things, and allows, for example, if we were showing clients how a building and an environment might work and how they might use it, it takes things on a huge step over a traditional sort of slideshow, or maybe even just an animation, a walkthrough.
Yeah, exactly. And this is what I'm beginning to see, obviously, now with the lockdown as well, and moving forward, who knows, where we have to start inventing maybe new ways of using buildings, and where companies are beginning to want to find new ways of interacting with their customers. Definitely there's a huge opportunity in developing new types of services. So for example, like universities, for the end of your show, how can we when headsets maybe get a little bit cheaper, or we're very, very, very early days in the development of all this stuff. So I think, well, I'm kind of betting on new needs, a little bit like we had the internet, come to life, and websites 20 years ago. There's still a lot to be done. Now everybody's doing Zoom meetings, so it's not far till we can all use our WSD keys,
And Gabriel on the Zoom chat has asked, what level of memory does your computer need to have? I'm sure that a lot of us are thinking this. There's all these, especially with all the updates you're mentioning and things. Could you?
As much as you can afford.
Yeah.
As much as you can afford, yeah. Yeah. Okay, we've got about 5 minutes left, so we could, if anybody on the Zoom meeting has another question, I haven't had any more come through on Facebook, we could take one more question, and then I will have to close down the meeting, unfortunately. It's been really interesting, but I don't know whether anybody else wanted to ask anything on the Zoom, or if any of you have anything else you wanted to say for the last couple of minutes, and then we'll sadly have to close down the meeting.
I suppose I just wanted to raise one point, or ask one question, just for the others in the room, of what we think the future of virtual reality is, because in a way, putting on a headset really allows you to become immersed in this. And I know that Unreal Engine supports, the use of virtual headsets, fairly seamlessly. So the idea is that at any point in the process, you can put a helmet on and walk into a space or a room, or view a design or whatever. But obviously we do tend to find that clients are a bit reluctant to put the headset on, and so there's a bit of a barrier. But yeah, I just wondered what generally we think the future of the virtual reality part of it is.
So yeah, there's certainly a lot of the companies that I work with placing our students into work placements and so on, the architectural visualization companies. that they use VR extensively. They use Unreal extensively as well, but not necessarily with both together. And I think one of the difficulties they have, and this is a practical exercise, is that at the end of the day, they're trying to sell architecture. They're trying to, as you are, you're trying to sell a design. You're trying to make someone pay for a particular design or buy a particular apartment and things like that. And one of the difficulties of when a client puts a headset on is that you've lost that contact. You've lost that eye contact with the person who's selling the salesperson, the marketing person. And so the experience of the space is fantastic, but the selling process is marred by that. It's disrupted. And so I think that's the next thing that really needs to develop is kind of augmenting virtual reality. So by being able to be in there yourself as well and have characters, whether it's an avatar or whether it's actual facial recognition, things like that, in some way, so that you can, so as well as giving the impression that your eyes are deceived into thinking you're in a space, you can actually see yourself in that space. I think that will be the next development, which will really help to transform the use of VR in that sort of scenario.
Yeah, if I may just add to this, is something quite interesting. I was told by one of the bosses of Unreal Engine, well, actually the boss of the Unreal Engine software. He said it's not so much about VR because of the fact that people don't, we're social beings. So as soon as we've got the headset on, we're cut off from everyone. And it's a bit anxiety provoking to be on your own in a big space like this. So the key really is interactive and real time. So after that, VR is just a mode of delivery, and like all modes of delivery, it's going to evolve, and then who knows what's going to happen around, around the corner. But one thing that's interesting, though, as he completed saying, is that Epic is always on the forefront of delivering, of integrating all types of delivery. Because of their gaming company. So, PlayStation, PC, Mac, mobile, headsets, everything. So that's a great thing also by using that software, that you don't need to worry about where you're going to output it. That's kind of Epic's problem. And it would just have everything supported.
Okay, thank you. Unfortunately, it's time to wrap up so that we can finish the Facebook Live. I just wanted to say thank you very much to all our speakers and to the people who've joined us and to the people on Facebook who've asked us questions. It's been a really interesting session. I'm sure everybody's now buzzing with lots more questions. We'll be on the Facebook, we'll put at the end a link to everybody's information so that you can go on their websites, you can check out all the things that have been shared. For the Facebook people, I'd like to say thank you very much and goodbye. For the people on Zoom, I won't make you finish the meeting immediately because we just need to say our goodbyes and thank yous properly. But to Facebook, thank you very much for joining us. It's been a pleasure. And I think Owen's going to now close down the live Facebook. Thank you.